So our next speaker is going to be Michał Daniłowski. Sorry about it. That wasn't quite perfect. But anyway, he is from Sano. He is going to be speaking about using Flower to build large-scale distributed deployments with varied learning based on the OpenStack piece of software. So with that, over to you.
Exactly. So thank you, Nick, for the introduction. So once again, my name is Michał Daniłowski, and I'm a master student. And I have a pleasure to collaborate with the Sano, which is Center for the Computational Personalized Medicine, and is international research foundation. And I will be referring a little bit to the announcement that Daniel gave us. So I was at some point wondering, like, yeah, we've got some clients, we've got the server, and I asked myself a question: how we can deploy it, like, quite easy. So I'm gonna show you like how to do it with the OpenStack services. Yeah, so basically what we are trying to do with federated learning is usually to simulate some process, right? Because usually we've got the problem with the data sets, which are usually centralized. So in order to simulate some kind of federated learning, we need to artificially partition the data and like run some simulation. And there are like many reasons why we need to do it, right? Both from the research perspective and industry. Like there are a lot of points that I've mentioned on the slide, such as performance. So we want to like learn our model in decentralized way as quickly as possible and minimize the gap between like the decentralized learning between like centralized and federated learning. So another point is scalability. So we want to identify our potential bottlenecks. Another point is about like privacy and security. So we would like to simulate some kind of potential attack methods or some other vulnerabilities to develop some mechanism for the defense. And of course, like we want to simulate some behaviors to use our resources and energy efficiently. And of course, like we would like to reproduce our results, right? Of course, like we always want to test some new ideas. So I'm gonna start with a quick introduction, like what is OpenStack, because I hear a lot of people who are talking about Kubernetes, and Daniel mentioned some public cloud providers, but there is still a project which is continued and developed, which is called OpenStack, and basically it's just open source cloud computing platform that provides us with set of software tools with which we can build and manage our cloud. So basically, it allows us as users to deploy some resources such as virtual machines or storage volumes and some networking resources. It's quite flexible solution just for running our workloads. So yeah, we can ask ourselves a question. We've got a lot of cloud providers. Like, what's the reason to use OpenStack? So as I said before, it's open source. It means it's free. So as long as we've got some servers, we can just install OpenStack software on it and use our private or like hybrid, however we deploy it, cloud. And it allows us for having this kind of opportunity to allocate and scale our resources as needed by our simulations and whatever we want to push there. So of course, like we've got more flexibility, which means that we can mimic production settings more accurately than using current Flower implementation on top of Ray, right? Yeah, so it also ensures us some kind of experiment isolation. And also on the slide, you can see that still like OpenStack is used on the production with more than 25 million cores, and it's widely used by companies from different industries, and also by some research centers and stuff like that. Yeah, so here we come with one of the core OpenStack services, which is Heat. So Heat is one of the orchestration services that are like widely available, that allows us to define and manage infrastructure as a code. So yeah, there is Heat, there is like Terraform. We've got many possibilities here. I'm gonna talk about a Heat, but of course, like it can be applicable for the other solution as well, which we can integrate with our OpenStack cloud, or integrate with other public cloud provider that we want to use. So it allows us to automate the infrastructure deployment, but also then to configure this infrastructure, which is like the most interesting for us, because we want to run some workloads on that infrastructure. So of course, the main benefit of it is that I can share my template with anyone. It can be reused. We can use it for collaboration, and also sharing some knowledge. Yeah, so some basic of the template. Heat templates use the YAML syntax, so it's quite easier than, for example, Terraform, which is using some its own language, its own syntax. Basically, Heat template define a stack. So stack is like kind of group of connected resources, which we want to deploy together. And Heat also another pro of the Heat is that it uses the same structure and abstraction as AWS CloudFormation templates. So it's probably not a very painful job just to migrate between those two solutions. So in a nutshell, like how the Heat template structure looks like. So we've got always 4 sections in this kind of YAML file. It's on the left top corner. 2 sections are required to provide. So one of them is like the version of the Heat templates. It's, as I said, still developed, so new capabilities are being added, and we want to keep our compatibility with older releases. So yeah, it gives us opportunity to use these templates for every other release that will come. And the second section is section with the parameters. So here we can specify some user-defined parameters that later can be used for the resources, which is the second part of the template that is required. And in this section, we can define everything related to what kind of resources do we want to deploy. And at the end, we can return some outputs, because Heat has like the Python client, the CLI. So we can print something or like use for another template. On the left bottom corner, like you can see some way of automate creation of some clients in let's say Flower example. So here we can deploy some free Nova servers. It means like the VMs with some specified image and flavor. And okay, once we have the server, so VM, we want to somehow configure it to run our specific workload. So the client code, for example, and this can be done with the cloud init. And basically, most of the VMs and server run this cloud init have this cloud init capability. So it's the process of booting the machine when we start the services like a network and stuff, and at the end usually we run something called cloud init, and it allows us to pass some information to the VM to run some specific workload. Yeah, and there is a simple scheme like how it works. So basically, we've got two inputs. One is with the static template, and one with the our parameters. And yeah, we can provide it to create some infrastructure. So yeah, I've talked a bit about the cloud init. So basically, it's our method to provide some user data to the VM, and once the VM is booted, it makes a HTTP request to retrieve the informations from the metadata server, and then it can bootstrap the VM with desired configuration. And the question is like, how could it look like with the Flower example? So in Flower, we usually have the server, right? And some number of clients. We would like to deploy some number of clients depending on, for example, the parameters that we want to provide. So it doesn't matter if it's like OpenStack or Azure or other cloud provider. We want to deploy some infrastructure. So basically, we've got always like this required parameter, which is version of the template. Then we can specify some parameters. Of course, like we can add more, we can add less, we can add some defaults, which are not necessarily provided by the user of the template. And then we've got the definition of the resources. So here I put some really basic example how it might look like. With just one VM, which we pass some commands to clone some repository, and then simply run the Python file. But of course, like in the real case, it wouldn't look like that. We would have like a lot of other resources. So because what's the main benefit under simulating on the real infrastructure? Like we have the access to create some resources which are not possible to simulate with Ray, such as like networking resources. So we can try to simulate some kind of simulation of unreliable network conditions. So we've got more impact on our infrastructure. So yeah, I'm thinking like it's a good example also for reproducibility. So we can not only provide the code of our client, code of our server, but also like how did we run it and how we can just copy and paste it somewhere on another cloud or another by another user and check the results, right? If they are correct and if we get the same metrics, right? Yeah. So that's basically about my talk today. So I just wanted to show you like how to use infrastructure as a code to deploy workloads on top of OpenStack. But of course, like we can do the same with other cloud provider, with other tools, and also like we can deploy not VMs, which are probably not the best solution, but also some Kubernetes cluster or some containers, which probably the next speaker will talk more about. Thank you.
Yeah, great. Thank you so much. Let's take one quick question if there's one around while the next speaker comes down. Yeah, we have a question over here.
Thank you for the talk. Very interesting. Well, I have two short questions. The first one is this YAML file you show at the end. Can we use it? Is it open source, and can we basically use the infrastructure?
Okay, so
to describe?
Yeah, I really like the idea that Daniel presented, that they want to provide some kind of templates, as I understand, like for deployment of the of the examples that we've got on the repository already. So yeah, I think that I can provide you some kind of template that will allow you to run some example from the repository. Yeah, but it's not currently available. Yeah.
Okay, thank you.
While the next guy is booting up, we could take another question. I have a question. So what are you going to build next? Now you have this great infrastructure. You can put Flower on OpenStack and so on. So what's the next big thing?
Okay, so that's a very good question because so I'm working on Flower for some time, like let's say on federated learning, and of course, like I started with researching some basic papers, but then I started like to asking myself a question like around the topic of my master thesis, which is gonna cover the topic of on-device federated learning for like medical application with the wearable devices. So it's not really connected with the talk that I gave just today.
True.
But still, I think it's important for the community, like to give them some tools to deploy the federated learning workloads. So that was just my thought when I saw the Flower that this small part of the deployment methods is missing, and I just. No,
you're absolutely right. A tool goes a mile, whereas like an application like maybe lives or die. So cool. Thanks for the talk. Great.